here's the question. Are there meaningful differences across SES in this part of the input, that is the wh-dependencies and syntactic diagrams that this learning theory embedded in the developmental computational models, says are important, right, in order to develop syntactic island knowledge? Well, okay. Let's first step back for a moment. What are the differences in this part of the input? That is, how different does this input look actually across SES? So here's one thing we can start with. We can measure the distribution of the relevant parts, the wh-dependencies and the syntactic trigrams. And one way to measure differences in distribution is to use something called the Jensen-Shannon divergence, JSDiv for short in our case, right? And it's a measure that ranges between 0 and 1. And if it's 0, that means that there is, not very divergent. You have identical distributions, and all the way up to 1 is, the most dissimilar distributions ever, right? So lower is better, right, when we're talking about how similar two distributions are. Now, let's talk about the input samples that we're going to use. So our high SES child-directed input comes from the child's tree bank. It's about 102,000 utterances, about 21,000 wh-dependencies, and this is speech directed at 25 high SES children between the ages of 1 and 5 years old. Now, our low SES sample comes from a subpart of the HSLLD corpus in the child's tree bank. So this is about 31.8 thousand utterances, about 3.9 thousand wh-dependencies. And this is speech directed at 78 low SES children between the ages of 3 and 5. And in case you're curious how SES was defined, it was defined by the creators of the HSLLD corpus according to two factors. So one is maternal education. So all of the mothers of these children had 6 years to some post-high school education at most, and the family's annual income, and that was 70% reported making less than 20K a year at the time this corpus was collected. And now, as a comparison corpus for these two, and you'll see why we need that in a moment, we looked at utterances of adult-directed speech from the switchboard corpus. This is about 74.6 thousand utterances, about 8.5 thousand wh-dependencies. This is adults speaking to each other over the phone, right? So adults to adults conversational speech. Now, what are we doing? Okay, what are we finding? What are we looking for? In particular, here's the question. Is high SES child-directed speech more like low SES child-directed speech? Or is it more like high SES adult-directed speech? That is, here's another way of thinking about it. If high SES child-directed speech is more like low SES child-directed speech, what does that mean? That means that SES differences matter less than who the speech is directed at, child or adult, right? It's the fact that you're talking to a child matters more than the fact that it's high SES or low SES. Versus if we find that high SES child-directed speech is more like high SES adult-directed speech, then SES differences matter more than who the speech is directed at. Child or adult, that's more similar within SES than looking across SES at children, right? So which is it? Does it matter? Do SES differences matter more? Does who you're talking to matter more? What do we find? Well, it turns out the first one. Whether we look at wh-dependencies or syntactic trigrams, we find the same pattern. Who you're talking to matters a heck of a lot more. High SES and low SES child-directed speech are more similar, right, compared with high SES child versus high SES adult-directed speech. In particular, if we want to look at the actual numbers for wh-dependencies, high SES child-directed speech is twice as similar, right, compared to low SES as compared to high SES adult, right? This number is half of that number, right? So this is twice as similar compared to that. It's the same thing that we find for syntactic trigrams. This number is half of that number, so high SES child-directed is twice as similar to low SES child-directed as it is to high SES adult-directed. So for wh-dependencies and syntactic trigrams, who you're talking to seems to matter a lot more. In fact, SES differences matter less, right? It's kind of our measurable takeaway, right? So this part of the input, right? This part, not any other part, but this part, looks pretty similar across SES, more similar than child-directed versus adult-directed within SES, okay? So that is a nice quantitative way to describe the input differences, right? Like that's what we've just done, is describe an input difference on this part of the input.